We're going to graph a linear inequality. The principles for graphing an inequality are very similar to graphing an equation, and we actually need to start by graphing what we will call our boundary line. And the boundary line is obtained by just changing the inequality symbol to an equal sign. So we're going to graph this line, y equals negative 2x minus 3. This is in slope-intercept form, so we're going to start by going down 3, and we'll make our first dot, and then it's got a negative 2 slope, so it's going to go up to the left. We're going to go up 2 and over 1. That's rise over run. We'll go up 2 and over 1 again, and up 2 and over 1 again, and up 2 and over 1 again. And this is where we've got to be careful. Things are going to be a little different. I'll make one more dot right over here. The first thing we need to notice is the symbol style. This is less than or equal to, and the fact that it's underlined right there, when we graph it, if you recall on a number line with an inequality, you have two choices. You could either have a hollow circle or a solid dot, and the underlined would give us a solid dot. Well, in this case of a linear inequality, the underlined inequality symbol is going to give us a solid line. So we could actually end up with a dotted line for an inequality, but in this case, it's going to be a solid line, and I'm going to just use something that will probably achieve something close to a straight line. I haven't figured out how to use this software to draw a perfectly straight line yet. But because it was underlined, we can use a solid line. And now here's where things get interesting. Now this says y is less than. So when it's less than, we've got two regions for this line. We have above and we have below. So I want you to picture if I was a ball sitting right here on the line, my ball would be on top of the line and it would be on the line the whole time. It would just roll down. But if I put a ball on this side of the line, it would just fall because it's below. So down here is what we're going to refer to as below, because it's below the line, and this over here is going to be above the line. In this case, below means less than and above means greater than, and this says y is less than or equal to. So we're going to actually shade this side. So you could take your pencil and we can kind of shade. And what that means is any point that's over here as an ordered pair would make the inequality true. So our original equality said y was less than or equal to negative 2x minus 3. So if I were to pick a point, like let's say this point right here, that's negative 3 comma 0. So let's try that. Negative 3 comma 0, and let's see what happens. I'm going to put y is the 0, and less than or equal to, and negative 2 times negative 3, that's positive 6, minus 3, and 6 take away 3 is 3, and indeed 0 is less than or equal to 3. So this point, this ordered pair actually makes it true. And if I chose something out here that's not in the shaded region like 0, 0, if I put a 0 in place of y, and if I put a 0 in place of all that x stuff and then take away 3, 0 is not less than or equal to negative 3. 0 is bigger than negative 3, so this is false. That's why we don't shade the side that's above. In this case, the inequality said only points below the line are correct. Now, because it's a solid line, all the points on the line are actually solutions as well, because of the equal to idea. Okay, now we're looking at an inequality, but you'll notice that we do not have y by itself. And so the first thing that we want to do is we want to solve the inequality for y. And that's going to require a two-step process. We got 2x minus 5y is less than or equal to 10. And I notice right away that it's underlined equal to, which means I'm going to be graphing a solid line, and we're going to go through a two-step process. The first thing we want to do is let's take away 2x, and because I want to keep things in slope-intercept form, I'm going to have a negative 5y on the left side, and then less than or equal to, I'm going to put the x next, negative 2x, and then that's a plus 10. And now we have one more step, which is to get rid of negative 5. We can multiply everything by the reciprocal, which is negative 1/5. But in this case, I'm just going to show divide the entire equation by a negative 5. And I'm going to put it under all three terms because a couple of them are going to disappear as fractions. So the negative 5 divided by a negative 5 becomes 1, and that's y. And this over here is positive 2 over 5, and we don't have to do anything with it. It's just 2/5 x. That's my slope. It's going to be up 2 and over 5, and it's a positive number. And a plus divided by a minus is a negative. That's minus 2. And you have to remember your inequality rule. We just divided by a negative. So this less than or equal to has to turn around and become greater than or equal to. And now I can graph it. Start by going down 2. And then we're going to go up 2 and over 5. So up 2 and over 5. And I'm going to go ahead and go down 2 and left 5. That's that dot. And this right here makes a line. And because it's underlined, I'm going to draw a solid line. And again, I'm not perfect at drawing straight lines. That's not bad. And it was solid because it's underlined. And we have to decide where to shade it. Look at that symbol. That symbol says shade greater than. Greater than is above. So above this line is up here. So we will actually go ahead and use our pencil and shade. Anything up here is going to solve the inequality. And the one point that we should always try 0, 0. Whether it's part of the solution or not, 0, 0 should verify it. So 0, 0 in this case at the origin is in my shaded area because it's above the line. So if I put a 0 there and a 0 there for x and for y, it should be true. And it turns out 0 take away 0 is 0. And 0 is definitely less than or equal to 10. So 0, 0 is true and our inequality is shaded correctly. We're looking at a situation now where we have a special line. There's just y, there's no x, and it's telling us y has got to be greater than negative 3. So let's take a look at the boundary line. The boundary line is y equals negative 3. And I noticed right away that this is just a greater than. It's not underlined. So when we see something like that, it's going to be a dotted line. So we're going to make sure that when we draw this graph, it will not be solid because it's not equal to. It just says greater than. Now, y is equal to negative 3. There's a point right there where y is equal to negative 3, and so is this one right here. All these points that are down 3 are all y equals negative 3. But remember, they're not part of the solution because this says y has to be bigger than negative 3. So what we're going to do is we're just going to make a dotted line at negative 3. And we want it to be obviously a dotted line and not a solid line. And it says greater than, and so greater than means we got to shade above the line. Well, above the line is either up here or it's down here. And greater than negative 3 for y, well, that's all these points up here because, there's y is negative 1. Negative 1 is bigger than negative 3. So is 3, 4, 5, whatever. All these points up here are part of our solution. And anything that I plug in up there will work. There's y equals 0. It's just, that's how you shade. It's above the line. If it was x equals, it would be a vertical line. And then if it was, for example, if it was x equals 4, I'll kind of shade that line up here. If it was x equals 4, or I'm sorry, let's say if it was x is less than 4, the boundary line would be x equals 4. And it would be a dotted line like this. And if the inequality said x is less than, well, less than is to the left because greater than is to the right. So if it was just this one and in the absence of all that purple stuff, that's where our line would be right there. So hopefully that gets you started on graphing linear inequalities.